Hi, everybody, and welcome to Astronomy 120. This is the online class. This is the normal start. There is another session that is going to start later on in the semester. So I'm sure that you guys are probably, it doesn't matter for you guys since we start now. Anyway, we were talking about earlier about the resource. So I just want to make sure that everybody is on board in here in terms of signing up to the course. Apparently, there is the college has a resource which is called the. Okay, I have to remember it. What is it? A bright wave with the BRYTEWAVE. So that resource should be able to give you access to the online book. So, and that's all we really need in terms of textbook. So we really need that textbook. So I want you guys to sign up as soon as possible in it because there are 2 units in that book. The book is nicely divided into units. It's not like those chapter textbooks where you have a lot of content that you need to go through in order to move from chapter to chapter. This is divided into units. Because of their small size, you will see that during the weeks, we will be covering at times 1 unit and at times more than 1 unit, probably 3-4 units. This week, we'll be covering 2 units, units 5 and 6. So this is how the textbook is laid out. And I want you guys to jump on it as soon as possible. That's why I started with it. That's one thing. The other thing also is that I'm sorry about the mix-up that happened. I know I already sent a message. I already went to Kempfer Zoom. I lined up the entire semester and everything was planned. And today, one of you guys sent me a message saying that the link is broken, which I was kind of surprised until now. I really don't know what happened. I sent them already a request to see what happened, but we signed up through the regular Zoom session, and I already sent a link. 2 messages already with a link. So hopefully for those who are not here right now, you need to pay attention to it. Obviously, this is a recorded session and it's going to be posted on Canvas so that for those who are not live so that they can see and know exactly what's going on. Okay, so those are the 2 items before we jump in. Any questions before I go in? No? Okay, so let me share with you my screen because we want to talk about this course and how it's laid out, and also in terms of the syllabus. And then we'll get into the content of this course, okay? So let me share with you the screen. I'm not gonna get into a lot of details. I know I already sent the syllabus about a week before the school starts. And hopefully you guys have had a chance to go through it and it's already available on Canvas. So hopefully you guys can go and jump on it and see exactly what's going on. For those who come in late, the meeting starts exactly at 2:10, so you didn't miss a lot. It was about 3 minutes of the session. So I'm going to share with you my screen. So what you're looking at right now, let me change it to the student view so that you guys see it from your vantage point. There was a link in here before that says Confer Zoom, but for some reason it's gone now. And I couldn't find it. It's not in the settings, as some of you, or at least one of you suspected. So there is nothing I could do about that at this point. Anyway, and the link I sent already should work for all of the meetings. Hopefully, the IT will fix this as soon as possible. Anyway, so this is when you come to the course, this is how it's laid out. So this is, you will see this, the intro here. This is for another class, not yours. This is actually what Spring 2022. And but the layout is more or less similar to your class, so hopefully you guys have had a chance to go through that. Anyway, when you come in here, it has some useful resources such as the syllabus, which we're going to talk a little bit about it. Something of a big, basically interest in here, which is part of the syllabus, honestly. Some links in here in terms of the Canvas. Basically, this is the textbook that we were talking about earlier. This is the course link, and I'm going to talk more specifically about this software in here. In terms of accessibility, should you really need help in that, please do not hesitate. Do not think that maybe things will, no, take advantage of whatever is offered to you by the college. And this is basically how the communications is laid out in this class. This is actually my private cell phone at this point, so that's fine. You can text me. This is my email address. The preferred way of communication is here. You come to the inbox and you send me messages. I usually try to respond as soon as possible, and there is a time limit of, it should be no more than 48 hours, basically, as long as it's not on a weekend. This is basically how this thing is. Obviously, you need to know my credentials for coming to this class. My name is Bouzidi Jamoui, and I go by DJ, as you can clearly see from my Zoom session. I have a PhD in physics from the University of California, San Diego. I taught astronomy, I taught physics, I taught actually engineering classes such as programming classes in different colleges. I spent a great deal of my teaching experience actually here in the San Bernardino Community College, mainly in the Crafton campus, but I also taught in 2019 here in Valley College. So I'm really not new to the campus, but with this Zoom thing, with this online instruction, so yes, I'm new to the campus in terms of that. I'm not really new in terms of the online instruction, so I have had that plenty of it. I have a YouTube channel, which I really recommend that you guys will subscribe to it at least during the semester. I will answer your question, David. At least during this semester, so that if there is an upload, which you will see a lot, relevant to your class, and the uploads, they will always have leading to them the name of the class. So if it's Astronomy 120, you will see Astronomy 120, and then whatever week is covering or whatever topic is covered. So if it's something else other than your class, then you shouldn't really be too much with it. This semester, I'm teaching mainly astronomy classes. I have basically 2 sections of astronomy and 2 sections of astronomy lab. Some of you are already enrolled in Astronomy 125, which is also another class that we do, but that's on campus class. So most likely we're not going to see a lot of recording for that class. So Astronomy 120, and I also have a Physics 101, which is an introduction course to physics also. And there is another course which I really do only, I don't do labs for it. Also, it's an on-campus class, which is the Physics 202, which is a calc-based course. So this is basically, so when you come to YouTube, you might see some titles that are kind of strange. Ignore them. Just focus on the ones that start with ASTR 120-70, which is your section. Okay, it's a good idea to subscribe to it at least during this semester. And after that, you may unsubscribe if you want to. Okay, I have 2 questions in here from David and Vanessa, and both of them are related to this access code. If you go and log in to Brightwave, you should be able to see the book there. If you don't see it, please let me know. And then when you click on it, it should give you the access code. Actually, you click to sign in, it's going to give you the access code to go to it, okay? Some of you already have done that. So if you have difficulty with it, please let me know. And then we will take it on a one-to-one basis. Sounds good? Okay. The other thing also that you might do is reach out to the bookstore, because they're the ones who manage these things. But I would be more than happy to meet with each and every one of you guys individually to make sure that you guys have access to the textbook. Sounds good? I have 3 questions already from Samantha, Vanessa, and David. Yes, guys? Okay, very good. Very good. So you can message me, and as I was saying before, the best way to message me is through the inbox in here, because then I will know exactly where you're coming from. Because sometimes when you send me a message about something that is you're having difficulty with, or a problem with the homework or something, or problem with specific assignment, then you don't specify your section, I wouldn't know. So I will have to really navigate and try to find what your class is. So with the inbox, if you go there, it's going to tell me exactly where you're coming from and which set of questions that you have, so I should be able to help you much faster. As I was saying before, other means of communications are fine too, namely emails and other ways of communicating. Okay, so there are some general resources in here that are available for you guys. Let me talk a little bit about the syllabus in here because this is our first session. So I'm going to download it in here. This is the PDF version and this is the online version. So whichever one you choose, it should be the same thing. So I'm going to click on the link. This is basically this is an old link in here. I need to fix this one. We're meeting Tuesday, Thursday at 2:10 p.m., not 2 o'clock. So, but as I was saying before, there was an issue. Hopefully we can fix it, okay? So, and I will tell you exactly what we'll be doing on those 2 days so that you guys don't get this thing confused, okay? This is the course description, typical stuff in here. These are the requirements for the course. This is a very, very important aspect of what we will be covering in this course, okay? The things that we will expect to do. So in a nutshell, this is basically what we will be doing, okay? So we will have an understanding of the astronomical phenomena associated with astronomy, okay? And then we will be able to make a scientific, basically, description, and based on the scientific principles, we will draw some conclusions, and then understand the motion of celestial objects. It sounds a lot, but let me put it down in a little bit simpler language. 3 things that we're going to be talking about. The first one is the solar system, namely the sun as a star. The planets, there are 4 inner planets that we'll be talking about, namely Mercury, Venus, Earth, and Mars. And then there are 4 outer planets, Jupiter, Saturn, Uranus, and Neptune. Then on top of that, we're going to be talking about the moons in the solar system, namely the Earth's moon, Jupiter moons, namely the 4 of them, the 4 big moons, Callisto, Ganymede, Io, and Europa, okay? We'll talk about Titan also from Saturn, and we'll talk about Triton from Neptune, and we'll talk about some more other moons, even Mars has 2 moons. We'll talk about the moons. Then we'll talk about dwarf planets. Dwarf planets include Pluto, include Eris, includes also Ceres, which is an inner, actually, dwarf planet between Jupiter and Mars. We'll talk about Makemake, we'll talk about Haumea, we'll talk about more other dwarf planets, Sedna and other ones, okay? Then we'll talk about the asteroid belt, the asteroids, which are part of the solar system also. And then the Kuiper belt, which is another belt surrounding the solar system. Those are more or less on the plane where the planets are. Then we're going to talk about the Oort cloud, which is part of the outer, basically, structure of the solar system. And that is not on the same plane as the other planets. It's actually a big spherical object. Among other things we're going to talk about, and that's probably the last item we're going to talk about, are the comets. Cool. So we have covered the entire solar system, basically, in terms of content. Then we're going to talk about the universe and the stars. Take our sun as an example. We go into different kind of stars. We see the classifications of the stars, that some of them are supermassive stars with different colors, with different temperatures, with different stages of their own life. We'll see something called the HR diagram, which depicts where the stars are in terms of their evolution and how they end up. There are 2 kinds of scenarios. The star is small, like our sun, is going to end up in a white dwarf. If a star is big, like, for example, Betelgeuse, which is part of the Orion constellation, that is going to end up either, I mean, in general, when they are big, they're going to be either a neutron star or we're going to be a black hole, okay? And we're going to talk about neutron stars and then also black holes. And neutron stars, we're going to talk about pulsars and all kinds of things in the solar system. Then forget about all the stars. We're going to take the entire collection of stars and talk about galaxies. Take our Milky Way as an example. Then after that, we're going to talk about group of galaxies. We have our own local group that is made up of a lot of galaxies, okay? Namely Andromeda, which is the biggest player in our local group, then our own Milky Way, which is another galaxy, and then Triangulum, which is a big galaxy in our solar system, and so on and so forth. I'm sorry, a local group, I'm sorry, okay? Then we take our local group and move on to a big cluster of galaxies called the cluster, basically the Virgo cluster. That's where we are. Then we're going to move bigger than that. We're going to talk about superclusters and even much bigger structures. We'll talk about the universe, talk about where the universe started from, what it's going to end up with. We're going to talk about life in the universe, okay? Astrobiology, and try to understand the possibility of ETs, basically, extraterrestrials out there. So it's a big deal. You guys see, in this class, we'll learn about everything. Yes, we're going to include the James Webb. As a matter of fact, those who are taking my astronomy 125, the lab, you will see some of the activities related to the Pleiades and some of the stuff that is related to more recent, basically, discoveries. So this is a big deal, okay? That's topic number 2. So we have so far solar system and the rest of the universe. Topic number 3, which is extremely important, and that is, how do we know all of this? We're sitting in our own tiny planet, looking at these huge structures that are unimaginably big, unimaginably large, and we're going to make conclusions where they're coming from. We're going to ask the question, what is going to happen to the universe? Okay, and we will not be here to know that, but we know what's going to happen based on observations. So we really need to understand the methods used by astrophysicists, okay, to be more specific, used to study the universe, to reach out to this big, vast, huge spaces and sizes that are of unimaginable, basically, sizes and things like that. So very good. Thank you, Vanessa. Okay, she answered Samantha's question. Anyway, the point being in here is there is a method that is used. We're going to, of course, try to build this method from the early methods on. One of the biggest questions that we're going to start with, how to locate objects in the sky. I mean, you go outside tonight and you look at the sky, the night sky, and you're going to see a lot of dots in there, okay? And those are, some of them are planets, some of them are stars, and you should be able to locate them in the sky. One of them is the moon. Obviously, you're not going to see the sun at night, but that's basically the stuff that you're going to be able to see at night if you decide to go tonight or any other night for that matter and look at the sky. So this is basically what we're going to be learning in this class. Sounds like fun, doesn't it? Sounds good? Okay, at least somebody else is sharing my excitement. Very good, thank you. More people now. Okay, so let me, since I'm still talking about the syllabus in here and some more stuff that is important in here, okay? This is the stuff that has to do with the grades. It says 2 written projects. We might end up with only 1 project, at least for right now, the monitoring of the moon for a whole 4-week cycle. That is what we're going to do. So in this class, okay, the midterms are 3 of them. There is homework and quizzes that are going to be assigned to this class, and participation, which I'm going to talk about, which is very important that you guys need to understand how to do your participation and get full credit for it. Otherwise, you can clearly see from here, if you ignore this one, you're going to be working off of 90%, which is not what I hope that you guys are planning to do. So you need to do that too, okay? And these are some of the stuff that is the plan, okay? Hopefully we will follow it as close as possible, okay? Some assignments are already there, so hopefully you're going to start on them. Okay, there was another item in here on how to reach me. I am on campus, I would say probably 4 days of the week. I live about 6 miles or less from campus. So if you decide to meet with me, I will be on campus, and I can still meet with you while from campus. Today, I couldn't go because of some other issue, but I should be on campus or on Zoom, okay? These are the times. If these times do not work for you, and I'm talking not just for the people who are here, but I'm talking also for those who are going to watch this recording later, please let me know. We can work out a schedule, okay? We can work out a meeting so that at least to fix whatever needs to be fixed, and to answer everything that needs to be answered, and to enjoy the class, to really enjoy it, and then hopefully pass it also with flying colors, so that everything works fine from all sides. This is my office, okay? At this point, there's a lot of basically things that they're trying to put together. So if you decide to come in there, that's fine, okay? Hopefully you're gonna, please do not come in unannounced. Let me know ahead of time. I think the office is locked because there are some stuff in it right now, closed, I should say, so that I can be there or open it for you and things like that. So this is right now. So ahead of time, let me know that you're coming, and we're more than happy to be there, or we can meet in the STEM Center where we can go through whatever you need and things like that. This is my office number. At this point, it's not rerouted from my phone, but that's fine. Leave a message there. I should be able to get it too. Okay, so this is some of the stuff that is related to how you reach out to me. There are, let me go to the day-to-day business. So this is basically the syllabus. I know that's not what you're going to be doing on a regular basis every day. Every day you're going to be coming into the models link. Okay, so unless you guys have another question on the syllabus, which I would be more than happy to answer right now or answer later on. So I'm looking at this content in terms of a student view. As you can clearly see from the bottom, it says student view, okay, or leave student view, or you are currently logged into student view. So this is how it looks like to you. Okay, so the first thing I need to do is go through this assignments one by one. There are some weeks in here that you can clearly see, but they are grayed out because they're still not available for you guys. We have to make them, I have to go through them and fix the dates and things like that on that. So the first thing I need to do in here is to go through the rules in here and read it and understand it, okay? If I don't mark it as done, it's not gonna work out for me. So in other words, I really have to read this one in here and mark it as done, okay? Right now it's marked as, it's not marked as done because it says that I didn't do it. Let me go back to the syllabus to show you the difference, okay? So right now, this one has a check mark next to it in here, but it's not checked. So as long as it's not checked, I'm stuck, okay? So if I try to move next to see what's going on, it's giving me, oh, I made it so that you can guys go. But the point being in here, you really have to do this one in here. You have to really, some other assignments, I'll make them so that if you don't do this, you're not going to be able to proceed forward, okay? So I'm going to mark it as done and then proceed. You will see this one on a regular basis, okay? The to-do things and the objectives of this units in here, okay? So the to-do gives you synopsis, basically, a big overview of what needs to happen in this week, okay? So the discussion in here that we have to do is, do we live on flat Earth? And if I click on it, it should take me to the assignment. There is another assignment in here, which is week 1 assignment. Both of them have due dates. As a matter of fact, the first assignment has 2 due dates. There's the August 24th due date, which is for the initial reply, and has an August 27th due date, which is Saturday, also for the peer replies. So both of these have due dates on them. Saturday, August 27th is the due date for the other assignment. So let me go through this one in here first. I click on it, it takes me to the assignment. Here are the instructions, and here is what it tells me I need to do on or before August 24th at 11 p.m. Then after I'm done with that, this is what I should do on or before August 27th at 11 p.m. I don't understand this, okay? And I really don't have time to go through this and read it and try to understand it and things like that, but I want to cheat if you wish. So what I want to do is check the rubric. Oh, this is what I'm supposed to do in order to get the full credit for this one. Okay, I need to do an initial post. I will get 10 points if all 4 items are included. What are all 4 items? Well, then I better read this thing. These are the 4 items. Okay, so I better do this. Okay, I better tell us about a little bit about myself and how I want to be called, and then include a picture of myself, and then share the link of a video or a discussion. What is that? Oh, relates to this topic. So I better now read this one. You guys understand? I am trying to reverse engineer how I should get full credit beforehand. Okay, trying to go through the rubric, and you will see this one typically with all of my assignments. You will have a rubric and how you're going to be graded. So you'll know beforehand how you're going to be graded, so that actually you can give it to yourself or to your peer, and they should be able to give you a mark based on what you did. The same thing. How do I get the rest of it? Because this is graded for 20 points. How do I get the next 10 points if I meet all the criteria for the second part? The second part has all of this criteria. Okay. So you're going to have, are the arguments against the flat earth based on science? Because some people, they just don't like the fact that people argue that the earth is flat, or they just go around it without scientific arguments. And if it's based on science, you're going to say yes. If it's not, then it's no. But of course, did the listed resource sound genuine or truly believable? So please don't leave it as yes, I agree, or no, I agree, disagree. Try to have it in full sentences. Do not forget about the first part of this assignment, namely the fact. Some of you already have replied. Do not leave it until I mean, in your communication, try to follow the ground rules, namely how you communicate. You really have to be respectful and mindful of how you're talking to other people, and basically using complete sentences, do not use all capitalization and all of that. What you're supposed to have done before this one when you check mark. Mark is done. Okay. So far, so good. Okay, for the few of you who came in late, as I was saying, this is a recorded session, so you should be able to, very good. So you should be able to at least follow. You missed about 25 minutes of material, so you can go later on and watch the first 25 minutes of this recording. Okay, and I probably will also talk a little bit more about this one. Okay, so now let me go back into the models again. So as I was saying in here, this is another assignment. There is a week 1 content in here, which takes me to the next thing in here. This is basically sometimes doesn't load as fast because of the fact that computer is kind of slow, or the internet is kind of slow right now. This is a summary, okay? This is not in lieu of reading the book. You really have to do the reading. This is just basically some points that you probably, after you read, you need to come back to this one in here to try to remember what's going on, okay? Some other resources also that are made available for you in here are the PowerPoints. There are 2 PowerPoints in here. And again, this do not replace the textbook, okay? They're just a summary of the notes in there. So they serve as guidelines, okay? And then this recording, today's recording, and Thursday's recording are going to be here in the week 1 live sessions, okay? Before I do that, let me talk a little bit about this one here, because that's another assignment that you have, guys, okay? So this is the discussion week. You're supposed to read, okay? And as you read, what is this? Yeah, that's fine. That is. Anyway, the point being in here is supposed to read the book, watch this recording. This is an old recording of one of my classes, okay? And watch some more videos in here. And then as you do that, you should be able to answer this question in here as part of your discussion assignment, okay? Now, already one of you guys have already posted the reply in here. Well, I am logged in as a student and I cannot see it because the replies are only visible to those who have posted at least one reply. Meaning I have to really honestly do the reading and watch the recording and do the notes and all of that. And there is actually another notes that you have in there, and then post my reply. Once I post my reply, I cannot edit it because the Canvas will show me that you edited. Please do not edit your reply, okay? Because if you do, you're going to nullify your reply. So please, please follow the instructions on all of the assignments to have full credit. Obviously, this one is going to be more obvious as we move along. You were wondering about where is that participation grade is going to come from? Here, by doing this reply. By doing the reading, by watching the recordings, if need be, by understanding the content, and posting a reply in a timely fashion on or before the due date. And hey, I secured my grade for this this week's participation grade. Okay, you're gonna get full grade if you do everything in here possible, 5 points possible, which is due by August 27th at 11 p.m. Sounds good, everybody? Okay, very good. Thank you very much, guys. Okay. So there was something I mentioned before, and I really want to talk about it today. And we probably are going to talk about it more actually for the people who are doing Astronomy 125. And that is this software. We're going to be referring to this a lot. As a matter of fact, the picture behind me in here, in my screensaver, is actually from that software called Stellarium. Stellarium is a free software. So let me click on it. I don't know, do you guys see the web page that says Stellarium? Okay, very good. So this software is a free software. You can have it on your desktop, whether you're running a Linux machine, including even the source code. You don't run the source code unless you're a programmer. So you have or a Mac machine. Make sure you download your own specific version because there are two types of Macs. There is the x86 and there is actually an ARM64, okay? So make sure you download the right version, otherwise it will not work for you. Also, the same thing is for Windows. There are two versions of Windows version. There is a 32-bit and 64-bit version, okay? If you're not familiar with this one, you can Google it, and if not, we can have a meeting and I can show you how to get into your system settings and download the architecture, the proper program for your own architecture of your computer. Usually, the 32-bit will work in a 64-bit, and the opposite is not true, okay? So that is really how these things work. Now, if all of this fail, you can still do the web version, meaning on a browser. This is a limited version, though. This is not as a full-scale version, okay? This is not the version that you're going to have on your on a full-scale thing, okay? Let me try to pull the version that I have on my phone in here, if I can ever quickly find it. That's also a limited version. I think the one on the phone also is the same thing as the web version. So this is my phone version, okay? As I said before, everything is free with the exception of the phone version. The phone version, the Android version or the iPhone version, they charge you, I think, like $299 or $499. I don't remember exactly because I got it a long time ago, but it's not free. So everything else is not is free, okay? I have it here on my computer, so I'm going to start this program first on my computer to show you how that works. So we get Stellarium. It's loading. Okay. Let me change the view because right now, when you first load it on the computer, it takes the full view of the screen, okay? I'm trying to find where is the minimization. Okay, here it is. Okay, very good. So now I can go back into sharing the screen. Share. So this is how it would look like. Okay, let me try to make it bigger. Okay. Let me fix this one in space and fix this one bar also in space. Otherwise, they float. They go in and out. Okay. Right now, it's detecting my location as on planet Earth in Loma Linda, 0 meters above the above the sea level. Okay. So this is basically what I think I am at. And for you guys, depending on where you are, if you are in San Bernardino, if you're in Colton, it's going to pick up your location depending on where you are. Okay. And that's the beauty of this software. It's going to, as I was saying, it's free for the desktop version, but the phone version is not free, but it follows you where you are. It also picks up the date. Right now, it's a military style date. It's the 2022 0816. At the time is 14/46/2021. That means 2/46, whatever the time is that you happen. If you don't like the time, you can freeze the time. Okay. One of the features that I don't like is, first of all, is the atmosphere. Okay, so we can remove the atmosphere. Right now, it's not daytime anymore. It's not like it's nighttime. It's still the same time. It's 2:46. But without the effects of how the atmosphere diffuses the light from the sun and everything, look, you can see nothing. You can see stuff in here. The other thing also, this is not how where I live looks like. I don't live on a farm, but it's a picture that comes with the software. So I can remove it also and look at the entire sky, okay? So this is some of the features that you have. One of the things that you can do also is control the date and time by clicking on that. And once you click on it, you can change the date. So if I'm planning to be on September, which I'm going to put 9 in here, September 22nd, I don't know what that day of the week is that, at 8 p.m. Military time, 8 p.m. is 20 or 46, which is almost 9 p.m. And I'm in my location right now. And let me put the horizon again. So this is how the sky, the night sky would look like if I look at the south, okay? The south, Saturn will be in the south, okay? Here is Saturn. If I look at the southeast, Jupiter will be there. Neptune, but Neptune, you cannot see it with your eyes, naked eyes. So these are some of the planets. This is the east, this is the northeast, and this is the north. If I look up, there is Polaris, okay? If I click on it, I get more stuff on Polaris. So this is really a very nice software that can give me all kinds of information about the object I can see, where I can see them. For Astronomy 125, we're going to be using this one extensively for our lab activities. For our class, we're going to use it to depict, among other things, the constellations, okay? To try to identify the constellations in the night sky. I'm having a small screen right now, so I can't see everything. So let me remove this one in here. And let me find a constellation. Oops, no, I don't want this. Sorry about that. Andromeda or Orion. Right now, Orion, on that day that I chose, which is September 22nd, it's below the horizon. So it's actually not in the season that I can see it. So I'm going to remove this one. So this is Orion's constellation. Okay, Orion's constellation has these 3 stars that are part of Orion's belt. It has Sape, which is part of its the leg. Rigel, which is the Arabic word for actually leg, which is the leg of Orion. Betelgeuse, which is a big star, which is the Arabic word for the pit, basically. Bellatrix, which is a goddess, has to do with war in the Roman culture. And this is basically the shield of Orion. This is basically, he's trying to pull trying to call it the arrow and trying to shoot Taurus. Taurus is actually here, which is the other constellation. Aldebaran, which is part of the big star of the Taurus constellation. Then you have Mars, which is a planet, actually, not a star. And below Orion, there is actually Canis Major, which is his dog, basically, while he's hunting. And this is Ceres, which is a big star in the night sky. The brightest star after the brightest object, actually, brightest star, I'm sorry, after the sun, the moon, and Venus is Ceres, okay? It is about 7 light years away from us in here. And it's just on the other side of Betelgeuse, which is a big star in the constellation in Orion. This one is Canis Major. So some of this stuff that we're going to be talking about down the road, so it's kind of nice to have this software. If we have access to the planetarium also on campus does that. The planetarium has this projector right now, it's sitting in the middle, and I think some of these features can be used there. We may be able to go and use it. If not, then we have the Stellarium, which is really a very good planetarium software used for when you're home, at home, okay? This is the Gemini constellation, Cancer, which are part of the Zodiacal Constellations, which is part of the signs of the Zodiac. Anyway, so these are some of the stuff that I wanted to introduce today concerning the software. So hopefully I get you also interested in it so that you can go and download it on your computer. Do not rely on the web version, it's limited. I showed you guys how to change the time. Actually, you can change your location. If you don't like where you are right now, you can change your own location in here on planet Earth or anywhere else, actually on Mars, if you want to be on Mars to look at what the sky looks like. And if you're planning a trip, for example, to go, I don't know, for example, the Grand Canyon or something, you can put the Grand Canyon in there on a specific date, and you can see exactly how the night will look like on that day, okay? It defaults to your computer location so that it picks up that location. If not, you can pick up whatever location that you have. So you can do all of these things. And it has some nice other features also that you can use. A telescope. As a matter of fact, let me try to find where is that planet Mars. If I take planet Mars right now, it gives me all kinds of information on it. And if I double click on it, it's going to take me to planet Mars since the time is stopped. So it's fine, I can zoom in on the planet. And as I zoom in on it, I see more and more features. This is the 2 moons of Mars. You have Phobos and you have Deimos, and you have the planet itself in here that you can zoom on it. So you can go on a trip across the universe using this software, which is like the planetarium, except it's on your computer. It's called the Stellarium. Okay, sounds good, everybody? Very good. Okay, so please do download it, regardless of how much we're going to use it. We're going to be using some of it in here in this class, and we're going to refer to it at some point during the class. Other software that we might use, they're not free actually, they cost about $20 something. One of them is the Universe Sandbox. I use it for simulations. Very good. And then the other one also is Space Engine that I might use also for simulations. And both of those, they have databases basically built in them, and they give you simulated basically values. This one is actually real stuff. This is how things are, what we know today, and what we will, where the objects are going to be in the future. So this is more of what a telescope would do for you, except that it's not like a simulation that you have from based on historical data, and you can build some, for example, how a planet can hit another planet, or how can you fly by, for example, a specific planet or something else that you can do with Universe Sandbox. And for those, you really need a better graphic card than you need a strong, good graphic card, gaming graphic card for those two. Okay, so we spent almost an hour right now introducing the class, which is fine. I believe that's important, that you guys really have to get into all of these things. As I was saying in the beginning, we'll be meeting on Tuesday and Thursday. Tuesday will be usually mainly we discuss the concepts, we go through the PowerPoints, and we introduce some stuff from Stellarium like this. Thursday, we will be more focused on the applications and try to answer the questions at the end, because astronomy And science in general is not really something to be read like a story. I mean, to be you have to really have your hands on it. You have to do applications. You have to crank in numbers. We're not going to get into a lot of math in this class, but I expect you guys to be able to do basic calculations. Okay, you divide a number by number, and then you will see the ratio of the two, and you should be able to tell which one is bigger first and how big it is, or how small it is. So you should be able to compare things to give you a sense of magnitude, to give you a sense of how things are. Okay, you should be able to plug in numbers and come up with calculations. So the second day, the second session will be more toward these things. Okay, and it's going to be as fun, if not probably more fun than the first one, where you're going to really be doing things and liking what you're doing, because you'll be able to do them on your own, okay, with no one else to basically push you to do them. Okay, you should be able to be proud of what you're doing. Okay, so this is basically how the plan is today. Since we spent a lot of time basically introducing these things, we're going to probably spend the next time also going through the concepts. Okay, so let me find my notes. That's unit 5. Share the screen. Okay. As I was saying, we have PowerPoints that are going to serve as a basis through which we're going to have discussions, basically start the topics. They're not replacement of the book. The book can be a hard copy like this one, or can be an electronic version. The electronic version should do fine. Okay, the electronic version should work for all of the things that we need to do. So one of you already sent me a message along these lines. So there is no need to get the hard copy if you already have the electronic version. Okay. So the PowerPoints will give us this base of how we're going to basically proceed. Okay. So first thing first, if you go outside tonight and look at the sky, you will see what looks like a scene above you where a lot of things are happening. Okay. Obviously, you should be able to look and see where is north. I am facing north right now. So if I face north, my right hand right now, I know it's because of the screen, it's projected in the opposite direction. My right hand should point toward the east. My left hand should point toward the west. Whatever is behind me is the south. Okay. Then there is the horizon. Granted, I mean, when I'm looking north, I see the San Bernardino Mountains in here, and I see, what is that, Big Bear and all of these things. Granted, if I am on a leveled plane, I should be able to see the horizon. If I go to the sea, for example, near the ocean and do the same thing, I should see where the sky meets the earth. Okay, that is my horizon. That is the horizon. Anything above that, I can see. Okay. Anything above that is where I locate objects. I can tell you, for example, hey, if I look north right now and I lift my finger for about 45 degrees, 34 degrees. Okay, this is 0 degrees. This is about 45 degrees, and this is 90 degrees. Okay, so about 34 degrees, if I'm looking straight up, I'm going to see Polaris. Okay, Polaris is part of a constellation, and that constellation is Ursa Minor. Okay, so I should be able to locate objects in the sky, basically based on my current location. You say, okay, how do you know 34 degrees? Because we are in a latitude, in a region above the equator by 34 degrees. The Earth has a spherical shape, and we are 34 degrees above. So when we look at the sky, our horizon and our zenith, which is the point immediately above our head, and our horizon, they make a 90-degree angle. And if I start looking up and up and up from my location, I can go from 0 degrees all the way to 90 degrees, which is immediately above my head. And then if I keep on turning my head, hopefully I don't fall, okay, I go all the way back to 180 degrees, and that's the maximum. That is the maximum. So this is the dome above my head is what is representative of my local sky, basically. If I'm in a different location, the sky would look different. If I'm on the North Pole, for example, Polaris will be actually immediately above my head, okay? And some stars that I can see here from my vantage point in here in the San Bernardino Riverside area, I cannot see them from the North Pole, and vice versa. Some stars they can see in there that probably you cannot see in here, and so on and so forth. Okay. So that is basically the whole mechanism in here. Obviously, the Earth is a whole sphere, and people in the southern hemisphere, they have a different sky completely than ours. Okay. As a matter of fact, if you go all the way to Argentina and down in those locations, you will not be able to see, for example, Polaris, no matter what time of the year it is. Okay, so they have to use different kind of stars to locate themselves in the night sky. There is an element in here that we cannot really replace, or we cannot really have, and that is the depth where the stars are. They all look alike on the same scene, okay, but they are not. There is a depth element that we really cannot distinguish. Some of the stars are actually closer to us than others. I mentioned 2 stars today, Ceres, which is the brightest star, it's about 7 light years away from us or something, versus Betelgeuse, which I mentioned today, which is several hundred light years away from us. Both of them appear to be in the similar to, I mean, one of them is an Orion constellation, the other one is in Canis Major, so they're very close from each other most of the times, okay? As a matter of fact, Rigel, which is another star I mentioned today, which is part of Orion, that is actually a different depth compared to Betelgeuse. So there is an element of depth in here. The planets, for example, they're a lot closer to us. Mars, that we saw earlier, is the second closest object to Earth, or the third closest object to Earth after the Moon, and Venus. Venus at times is going to be far away, but at times is going to be the closest object to Earth after the Moon. Okay, so those are, there is an element of depth, and we see them all in the same night sky. Okay, the Moon appears bigger than Mars or even Jupiter, although Jupiter is 1,000 times bigger than the Earth in terms of mass, and it's about 10 times bigger in terms of diameter. Yet it's bigger, a lot bigger than the Moon, yet it appears smaller. Why? Because Jupiter is far away compared to the Moon. Okay, the Moon is very close and appears bigger in our night sky than even the Sun. Or I'm sorry, it appears the same size if we really look at the Sun. It appears the same size. That's why there is a lunar eclipse, because the moon can close completely the Sun, and there is actually so that's why the solar eclipse, yes, because the Moon covers the Sun during daytime when it's a new moon. But compared to other planets, for example, it appears a lot bigger because it's a lot closer. Obviously, the Moon is not the same size as the Sun. Okay, the Sun is 1,000,000 times bigger than the Earth in terms of mass, and it's a huge one. But during a solar eclipse, the Moon will cover it completely. Why? Because it's a lot closer to us. So there is an element of depth in here that cannot be represented, at least on the night sky. Other than that, the positions can be located. Okay. As I was saying before, also, we have 2 different things that we really need to understand. There is constellations and there is asterism. Both of them are subjective representations of the night sky. you go out and look at this night sky, for you, this stars in here, depending on how you envision them, you might look at them differently, but different cultures represent them as a lion. So this is Leo, the constellation Leo. Okay, so it depends on the culture. Depends on the culture. I'll try to find the link to the movie. I don't know if you guys have seen it or not. What is that cartoon movie? Simba, Timon, and Pumbaa. You remember that? Have you seen that movie? The Lion King. Yeah, The Lion King, where the three of them were sitting out and looking at the night sky and talking about the stars. And each and every one of them replied to basically what the stars were. I think it started with Timon saying that the stars are just bugs that get stuck in the night sky, basically, and flying bugs, basically. And then Pumbaa basically replied, no, they are more like a gas that is burning billions of light years, billions of miles away from us. And that's actually the closest one to the correct answer. And then Simba actually answered that it's more like the stars are some sort of old kings that come out and help us and things like that. But the point I'm trying to make in here is each and every one of these people, they have a different take on what those stars represent in the night sky. And this is true for the different cultures. The Polynesian cultures, for example, they have different representations than the Greeks, and the Arabs, and the Indians, for example, the Chinese, the different cultures, they have different representation. The South America, the Mayas, for example, they have different representation, interpretations of this night sky. So when you look at the objects in the sky, you might see shapes. Now, the constellations are classified into 88 constellations. Basically, that's the official number, and there is a map for each and every one of those constellations, okay, associated with it. And on the map, let me share with you another screen in here. I can find it for some constellations, a couple of constellations. Let me first of all find where this was in here. This is Aquarius. This is Orion, since we talked about it already. So let me stop sharing that screen and let me share with you this picture in here. So this is the constellation Orion. Orion, if you can clearly see this blue line in here that you can see in this picture, this represents the path of the sun, called the ecliptic. Okay, the sun passes through this line in here throughout the entire year. Apparently, it's actually the Earth that is passing through that line, giving us the impression that the sun is moving through that. We'll talk about this down the road. So the point being in here is, this is, if I trace the position of the sun day in, day out, throughout the year, this is how it's going to move. And it's going to move through some constellations. And here I see Gemini, I see some other, I see Auriga, at least on the top in there. And this constellation, Orion in here, this is its map, okay? The boundaries of the constellation, okay? So this is its constellation. This is actually the asterism associated with it. This is different shapes, if you wish, that you draw following the different stars that you see in here. This is the belt in here, for example. You have a Nitaq, you have a Nilam, you have a Mintaha, which is all part of the belt, the 3 stars part of the belt. As a matter of fact, with the exception of a Nilam, the other 2 stars are actually not single stars. There are multiple stars next to one another, okay? And then you have Safe, and you have also Rigel. And in here, you have the sword of Orion, actually. And there is all kinds of stuff that is in this constellation. So this is a constellation. It has asterism. So asterism is a group of stars that you can recognize. The shape, basically. It's not a constellation, but basically shape that you can recognize. Canis Major in here, and this is the star in here that you can see below it. If you look at the bottom in here, of this is from Wikipedia, by the way, this page, you will see different numbers associated with all of the stars. And it's giving you in here how bright they are. if you see the brightness in here, the smaller it is, the bigger the star, the brighter the star, I should say. So -2 is super bright. -1 is the next one in brightness. 0 is actually brighter than 1 and 2 and so forth. Any star that has a brightness higher than 2, usually it's very hard to see, especially when it's cloudy or when it's light polluted area, like when we live in here in town. So when it's towns, when there is a little bit of stuff in the sky, it's very hard to see any star with a magnitude that is bigger than 2. Magnitude that is less than 2, usually it's especially 0 and -1 and -2, even with light pollution should be able to see. So the brightest star, as I was saying in the beginning, is actually Ceres, which is in here, okay? But it's not part of this constellation. So just to give you an idea what the different constellations are, okay? This is Taurus, and this is Aldebaran. If you notice also in every constellation, there is a designation, a Greek letter designation. There is an alpha in here. There is a beta for Rigel. And if you know the next letter that comes in the Greek letter alphabet is gamma, alpha, beta, gamma. And then if you follow the Greek alphabet, there is a delta, there is an epsilon, there is a chi, there is a kappa, there is a lambda, and there is different letters in here. Is this a chi or what did I say? This is zeta. Sorry, zeta. Okay. The point being, and there is a bunch of pi's in here, pi 1, pi 2, pi 3, so on and so forth. What does all of this mean when you look at the chart like this one in here? Alpha is the brightest star of that constellation. And all of the stars have this official name, an astronomical name, which is the Greek letter associated with them, followed by the constellation, the 3 letters of the constellation. So Betelgeuse, you can call it Alpha Ori, because it's the alpha star of the Orion constellation. Then Rigel will be the Beta Ori, because it's in this case beta, and it's part of this constellation, and so on and so forth. Okay. Bellatrix comes next, which is Gamma, Ori, and so on and so forth. Okay. And the same thing is true in here. Alpha for Canis Major, I think what is CAM, and so on and so forth. Okay. So this is basically, in this case, Aldebaran will be your alpha TAU. Okay, so on and so forth. So this is how these constellations are. Now there are 3 types of constellations that you need to be aware of. There are the zodiacal constellations that are part of the signs of the zodiac. I already mentioned Taurus in this case, and you have Gemini, and you have Cancer, and you have all kinds of other constellations. Okay. And then there are seasonal constellations like Orion in this case. And then there are constellations that are always visible. Cassiopeia, for example, is one of them. Ursa Minor, for example, is another one. These are always in the night sky, no matter where you are, at least in the northern hemisphere, okay? Because they spin around the Polaris. So they're called oh man, the word is. Basically, they're always there. They always circumvent, they go around the Polaris, okay? So there are 3 types of stars. Those that appear, that are part of the signs of the zodiac, those that are every season, and those that are always in the night sky, no matter what time of the year you are, no matter what, sometimes even during the same night. Like for example, Cassiopeia, that has a shape of W. Sometimes it's a W when it's below Polaris. When it's above Polaris, it becomes an M. What is when it's on this side, it becomes actually this side becomes a 3, and the other side they flip 3, and so on and so forth. Okay, that's 5 stars in it, and the 5 stars form the shape of W. Okay, when it's below Polaris. So anyway, this is what we talk when we talk about constellations. Okay, we still have about 15 minutes or so. Okay, so let's continue the discussion that we started in here. So again, the stories associated with them, the myths associated with them, they really depend on the culture, as I was saying in that. Okay. So it's not a unique story. Think of, again, there are 88 of them. Okay. Some important constellations. You have the Big Dipper, the T-top. You have Cygnus in this case in here, which is another, which is a swan. For me, it looks like an X, but some other pair. Here is how it actually looks like. Okay. So can you draw a swan out of this? I don't know. Okay. So again, this is a culture, it depends on the culture and how you can look at stuff and things like that. You will notice also a lot of the stars have Arabic names, and because of the contribution, how they were naming these things. So Betelgeuse, for example, Saif means the sword, literally speaking in Arabic, and also Rigel, and a lot of these things, and some of them actually come from the Greek naming. So there is a kind of, and now we have the scientific names, as I was saying before, okay? Okay, the zenith, I mentioned it earlier, and actually it's an Arabic word, which means immediately above your head, or the tip of your head in Arabic. That's actually when you are standing on the ground and you look up, that is your zenith. So what you see in top of, above of you is actually the zenith. So the stars that are in there, they're coming from, that's what you describe as zenith. Obviously, if you're North Pole, okay, star that is in your zenith is going to be, in this case, Polaris. Okay, if you are in our region, the zenith, of course, if you look at the sky, any star that has the latitude of about 34 degrees, that is going to be part of our zenith. Okay, when you look at the night sky, depending on when it is, when it comes out, then it's going to be in your zenith. Obviously, it's going to move because the Earth is spinning. Okay. Then in the opposite to the zenith, the word in Arabic is nadir. Okay, the opposite, really, that's what the word means. So when it gets translated first from Arabic to Portuguese, then from Portuguese to French, then from French to English, at the end of the day, they lost the H in here and became nadir. Okay, that's the opposite. So the zenith, and the opposite to it is the nadir or nadir, okay, however you say it. Okay, the Earth is tilted a little bit. The equator of the Earth is the line that separates the Earth into a northern hemisphere and southern hemisphere. Okay, so anything above in this case is part of the northern hemisphere, and anything below it is part of the southern hemisphere. If you are on Polaris and you look straight up in the sky, anything, Polaris cannot be on Polaris. If you are on the North Pole, okay, and you look up in the sky, that is going to be the north of the celestial sphere. So that's basically how astronomers divided the sky. They took the Earth and they projected it into space, okay? So the equator will have a corresponding, so the equator on the Earth, the inner structure, will have a corresponding celestial equator. The North Pole on Earth will have corresponding north celestial pole. And the southern, basically, pole near Antarctica will have a south celestial pole. We don't have a star, as I was saying before, to point to in the southern hemisphere like we do in the north hemisphere, which we have the North Pole, or the northern star, that's what it's called sometimes. We don't have that. There is an asterism near the southern pole, southern celestial pole, that we recognize with it, that we know how that we are, where we are, at least in the south. And as I was saying, the celestial equator is the projection of the equator of the Earth. So now we divide the sky accordingly to the northern hemisphere and the southern hemisphere. Stars that are part of the southern hemisphere will never be visible to us, depending on how far they are from the equator. If they are below the horizon, you will never be able to see them. Vice versa. People who are in the southern hemisphere, they cannot see some stars in the northern hemisphere, so on and so forth. Okay. So this is how the geometry of the sky is. Okay. Again, this is our local horizon. So you will have your own local. All of this depends on where you are on Earth, okay? This is the word that I forgot earlier, circumpolar constellations. So there were circumpolar constellations, zodiacal constellations, and then you have seasonal constellations. So those are the three types, okay? Circumpolar, in this case, a star that moves around the North Pole and will never set, will always be there, okay? But you have stars that rise and fall because of how the Earth spins, okay? Depending on how far they are on the night sky, okay? So that is basically, and it's true also for constellations too, okay? Okay, on Earth, we locate objects using polar coordinates, okay? I'm sorry, polar coordinates, you're using spherical coordinates. So let me go back in here and try to show you what I'm saying in here, at least. Share with you Stellarium. It's showing me my location, Loma Linda, and so on and so forth. That is my own location. Yours might be different. So if I try to go into a location, no, that's not the one. What is the location? Yeah, location. Okay, here is what I mean. I mean the latitude of where we are right now, what I am at right now is 34 degrees north above the equator, 34 degrees, 3 minutes or arc minutes in this case, not minutes time, not the clock minutes, okay? 15.85 arc seconds. So you take a circle and you divide it into 360 degrees. 0, and then you go above the 0, 34 degrees. 0 is the equator, and then you go 34 degrees. If you continue up to 90 degrees, you're going to find the North Pole. If you keep on going to the opposite degree, which is from 0 to 180, you will be on the other side of the Earth. In other words, if I tunnel through, if I build a tunnel, I'll find you on the other side. If you continue all the way back, you're going to be 360 degrees where I am right now. So this is how we locate objects on the Earth, and that's how we do also on the sky. We use also something similar to it, okay? Now, the longitude, it goes from east to west. By convention, we took Greenwich as the starting point. Greenwich, which is the prime meridian, that is where the location of the 0 degrees is. Then we start counting. Are we going first of all east toward China or west toward the United States? Okay, we are west by 117 degrees. So again, we took that circle going from that line, prime meridian, which goes through the city of Greenwich in England, and come back, and that is 360 degrees. If we go 117 degrees west, that is where we are. That is where I am at. Okay, from that line. 15 arc minutes, meaning take a degree and divide it into 60 arc minutes, just like you take an hour and you divide it into 60 minutes. And each arc minute, you divide it into 60 arc seconds, just like you take a minute, a time minute, and you divide it into 60 seconds. That is how things are measured in here, okay? So this is how they are represented on Earth. So if I choose a different location, it's going to move this object in here. Oops, I don't want to change. So if I go south, I am here now, southern hemisphere. Let's change the number in here. Now it looks different, okay? I'm moving up 20 degrees all the way to 0 degrees. 0 degrees should put me on the equator somewhere on 0 degrees. So right now, this is where the equator passes through, what is it, Central America, then Africa, and so on and so forth. So that is 0 degrees. Obviously, this is not full 0, unless I bring this number down. This is actually, I have to bring this one also down to 0. And this one actually to 0 too. Oh man, this is hard to do. Anyway, so in here, I'm going to go also it's going to be different. Let me bring it to 0. Can I type 0? I'm not sure if I could. Apparently it could. But it did not move this object. It should really move all the way near, somewhere in here, near Africa. Okay. Anyway, this is how we locate objects on Earth. In a similar fashion, and we're going to close with that one, we do the same thing actually for the night sky. Except, there's a big except in here. Okay. The night sky, again, we're going to go with degrees again from 0, then 20 degrees, 40 degrees, 60 degrees, 80 degrees, 90 degrees. Below that, it's going to be negative 20, negative 40, negative 60, and negative 90 degrees. 90 degrees put you back on the, so we go from negative 90 all the way to positive 90, okay? So this is the declination, similar to the latitude. The latitude was on Earth, going up or down, okay? And here, it's going, again, on the celestial sphere, we're going to call it the declination, okay? And then, instead of dividing it into 360 degrees, going from 0 degrees to 360 degrees, we're going to go 1 hour, 2 hours, all the way to 23 hours and 59 minutes and 59 seconds. After that, we're back to 0 hours. 24 hours, basically, we divide it. Just what we divide the clock. So this hour in here, which is called the right, the right ascension, this is similar, if you wish, to the longitude, except the longitude is measured in degrees. Okay, this one is measured in hours and minutes and seconds and so on and so forth. Okay. Okay. Hopefully, you guys will read this unit and the unit before it, okay? And again, the purpose of those units, the coordinates, is actually to locate objects in the sky. When we meet on Thursday, we're going to continue this discussion. We're going to continue basically Unit 6, actually, and try to build, first of all, this one's in here. We're going to look at Stellarium again. We're going to see some objects in the night sky, and we're going to try to find their locations and what we mean by the J2000 basically location of that specific star or object in general. It doesn't have to be a star, it could be a planet. And then basically how we locate objects in the night sky, we can identify them. So this is the continuation of today's topic. And we're going to talk next time when we meet also about the cycle of the Earth around the sun, the year basically, the period. And we're going to talk more about the constellations. If you go and look at any kind of, by the way, we don't learn anything about astrology. This is not an astrology class. This is an astronomy class, okay? There is a big distinction. Astronomy is science, and it's actually the one that laid the foundation for a lot of science and physics and chemistry and all kinds of fields of science. Whereas astrology is not science, okay? We're going to talk about that down the road. I know the previous units that we didn't cover go more in depth on this one in here, so we don't talk about that. But we'll talk about the constellations because there is something that is important in here. So the signs of the zodiac, there are 12 of them. And you will see that there is actually a 13th sign that needs to be included in between some of the signs, otherwise there is a gap between those two constellations. Anyway, I hope to see you guys on Thursday, and I'm hoping that the problem that we had with the Confer Zoom will be fixed by then. If not, we're coming back to the same link, and I will send you a reminder again with the link, just to make sure that you guys have that link. And for those who need to meet to fix whatever issues they have with the course online, please send me a message. And I will schedule also a meeting so that we can meet and make sure that we work out whatever issues you have and be able to get your resources. Sounds good, everybody? Very good. So, thank you, guys. And this recording will be available probably later at night or tomorrow morning. I'm going to stop the recording.